In classwork 2, we will be graphing a function using an increasing or decreasing portion to make it become a true inverse. What happens when a function does not pass a horizontal line test is you have to restrict the domain to one particular part that will pass the horizontal line test. Now you know from your transformations we have a graph of a parabola that is going to be going 2 to the right and 4 down. The minimum point, and you can do the minimum on your calculator as well, the minimum point is 2, -4. If we gave this parabola a horizontal line test, it would fail. So at the minimum point, we are going to look for the decreasing side of it and the increasing side of it. And we will be able to see which one is which. So at this point, we are going to take the increasing side. The increasing side's domain, since we restrict it, the restricted domain will then be from 2 to infinity. The range will be the same regardless, from -4 to infinity. Our one piece will look like this. Now, if you put this in your y equal, and you do this, put an extra set of parentheses around this, and then limit your domain. Restrict your domain to greater than or equal to 2. And that will give you just this one piece. You can then do a draw inverse, or you can take your table and interchange your x and your y and draw your inverse. This point right here is the important point. If you take 2, -4 and you interchange the x and the y, you get -4, 2. And this is a reflection through the line y equals x. Now we're going to find your equation for this line. So you are going to interchange the x and the y. F of x is y. You're going to put x is equal to y minus 2 squared minus 4. Solve for y. Add 4. And then take the square root. And remember, when you take the square root, you get a plus or minus. And again, solve for y. Add 2 to both sides. Notice at this point, you have two equations. 2 plus radical x plus 4, 2 minus radical x plus 4. Since we're using the increasing part, we want the 2 plus. So we give it their inverse, and we get this, and that will be this little line right here. You can then put it in your y2 and check to see that it draws over your inverse. At this point, let's look at the domain and range of your new inverse. Your domain and range of your original function, x was the domain, y was the range, will swap out as well with your inverse. The domain, the x value, will become the range, which will give you 2 to infinity. And if you look at this point, we are at 2 to infinity. Your y will swap out and become your x, which is your domain. And your new domain is now -4 to infinity, which fits your new function. Now we'll try a function, and we'll take the decreasing side. Here's an absolute value function. You're going to put this in your calculator in your y1, and you're going to see, after the transformations, shift horizontal to the left 2, go up 5, you get an absolute value that looks like this. Do a minimum on this, and this minimum will be -6.677, comma, 5. Now the -6.77, that's 2/3. So we're going to make this -2/3, comma 5, just so that we get exact in this vertex point. At this point, we're going to cut this right here and say this is its decreasing side, this is its increasing side. So this time around, we want the decreasing. So we want a function that's piece of that's going to look like this. And this point right here is negative 2/3, 5. If you interchange negative 2/3, 5, you get 5, negative 2/3, which would put us here. And you can kind of see that your line, to be symmetrical over the line y equal x, will go out this way. Okay. Now, you can do this in your calculator again. Put it in your y equals. Put an extra set of parentheses around it. Use your absolute values. And limit your domain to x is less than or equal to negative 2/3. That will give you the domain coming from this end. And draw inverse. See that this is your draw when you do your draw inverse. Now let's find the equation for your new function, for your inverse function. Replace the f of x with y and swap them. So we're going to get x is equal to 3y plus 2 plus 5. You've got to solve for y, so subtract 5 from both sides. At this point, I like to switch these and put my absolute value on the left-hand side. If you remember your absolute values, you always get a positive path and you get a negative path. This time, we want the negative path. The 3y plus 2 is equal to the negative of x minus 5. Okay, and we're going to distribute this, and then we're going to solve for y. So we're going to subtract the 2. 3y is equal to negative x plus 3, and divide by 3. If you were to graph this function, you would get a line. So our inverse has a little bit of a problem. We do not want the full line. We only want part of it. So what we're going to do is we're going to restrict its domain. Remember, the range from the problem, the original problem, becomes the domain for this problem. So look back at your range and your domain. Your domain in using your decreasing was negative infinity and stopped at the negative 2/3. Your range is 5 to infinity. We're going to interchange those. Your domain is going to become your range, and your range is going to become your... So your domain will be 5 to infinity. And your range will be negative infinity to negative 2/3. This restriction is the one we need to keep next to this line so that we get just that portion of the line. We do not want the entire line that goes back all the way. We just want that one portion. And that gives us an inverse for when we restrict a domain.